This week we start our study of right triangles. Today we will begin with Pythagorean Theorem. When two of these three sides of a right triangle are known, the third side can be found by using Pythagorean Theorem. Pythagorean Theorem states that the square of the hypotenuse is equal to the sum of the squares of the legs. So hypotenuse squared plus the leg is equal to the leg squared plus the other leg squared. But we need to know how to label those triangles. First, the easiest thing to label is the hypotenuse. It is directly across from the 90-degree angle. It's the long side of the triangle. Next, we need to label the legs. Each side length of the triangle is the leg. So you have the hypotenuse, which is across from the 90-degree angle, and each leg that make up the 90-degree angle. We also, when we're working with Pythagorean Theorem, normally label the side lengths A, B, and C. Each leg is either A or B. These can be interchanged. But the hypotenuse is always C. So then we can write the Pythagorean Theorem as A squared plus B squared equals C squared. So let's look at our first example. We have a triangle that has a leg of 3 and another leg of 7, and we're looking for the hypotenuse. It is easiest to label each leg A and B, and then label the hypotenuse C. This helps us when we're filling in the formula for Pythagorean Theorem. To start off, I write A squared plus B squared equals C squared. My A value is 3, so I plug that in. 3 squared plus my B value, which is 7, that's 7 squared, equals X squared. We don't know the value for C, so we fill it in with X, and that's what we're given as well. So then we do the math behind this. You could do this with your calculator by using 3 squared plus 7 squared and plugging it into your calculator. As you'll see here, it's 58. But let's look at it if we didn't have our calculators. Three squared is 9. 7 squared is 49. So 9 plus 49 is equal to X squared. If you add 9 and 49 together, you get 58. That is equal to X squared. Now, to get rid of the square, you have to take the square root. Remember, what you do to one side of the equation, you must do to the other side of the equation. So when I take the square root of X squared, I have to take the square root of 58. The square root of 58 is equal to X. Our next example has a triangle with a leg of 6, a leg of X, and the hypotenuse as 6 square root of 2. Again, let's label our legs and our hypotenuse. A, B, and C. This 6 square root of 2 is the whole value for C. It looks a little funny, but we can plug it into our calculator, which I'll show you in a few minutes. So let's start by writing out the Pythagorean Theorem. A squared plus B squared equals C squared. Our A value is 6, so we know that's 6 squared plus our b value is x, so we have to fill in an x there. X squared is equal to the whole value of c, which is 6 square root of 2, all squared. If we use our calculator, we can plug that in. 6 times the square root of 2, and you have to make sure you use your parentheses here, all squared. We see that that equals 72, and 6 squared equals 36. So we'll fill in those values into our equation. (36) plus x squared equals 72. Now we have to solve. We'll subtract 36 from both sides. So we have x squared equals 72 minus 36, which is 36. Then we have to get rid of the squared. We do so by taking the square root. So x equals the square root of 36, which is 6. Our next problem doesn't quite look like a right triangle, but we can make it. If we extend the side length, we've just formed a right triangle. The length of one leg is 8, and the length of this leg we have to find out. The whole thing is 11 from here to here, and this segment is equal to 5. So 11 minus 5 equals 6. Now we need to label our sides for Pythagorean theorem. A, B, and C. So we'll solve the problem, starting with writing the Pythagorean theorem. A squared plus b squared equals c squared. Our a value is 8, so we have 8 squared, plus our b value, which is 6 squared, is equal to c squared. 8 squared is 64, plus 6 squared, which is 36, is equal to c squared. 64 plus 36 is 100, and that is equal to c squared. We need to take the square root of both sides. The square root of 100 is 10, and that is equal to c. We could have plugged this part in our calculators. If we'd done so, it would have looked like this. And we could have skipped this step right here. Just a little helpful. Our next problem says find the length of the diagonal of a rectangle with a length of 8 and a width of 4. First, I would think you need to draw a picture. You have a rectangle with side lengths of 8 and 4, and you're looking for the diagonal that goes across. If I could draw straight, it would be a better picture. But you're looking for the measurement of that diagonal. If you notice, we have a right triangle, so we can use Pythagorean theorem. A squared plus b squared equals c squared. We need to label our side lengths, A, B, and C. a squared should be 4 squared, plus b squared, which should be 8 squared, is equal to x squared. 4 squared is 16. 8 squared is 64. That is equal to x squared. 16 plus 64 is 80, which equals x squared. And remember, to get rid of the squared, we take the square root. So x is equal to the square root of 80. For today and tomorrow, we'll leave the answers in their square root. Wednesday, we'll figure out how to rationalize or simplify the radical. So the length of that diagonal is equal to the square root of 80. The next problem says find the length of the diagonal of a square with a perimeter of 24. Again, you need to draw the picture. The square has a perimeter of 24. That means we added all 4 of its sides together to get 24. So in order to find each side length, we divide by 4, and that is 6. So each side measures 6. We want to find the diagonal of this square. Again, we go ahead and label our sides A, B, and C. Then we can start with our Pythagorean theorem. A squared plus B squared equals C squared. Our A value is 6, so it's 6 squared, plus our B value, which is 6 as well, so 6 squared, is equal to C squared. 6 plus 6 squared is 36, plus 6 squared, which is 36, equals C squared. 36 plus 36 is 72, and that equals C squared. And remember, to get rid of the square, we take the square root. So the square root of 72 is equal to C. The last problem has a very odd looking shape. We have a rectangle with 2 right triangles on the ends. What we need to do is find the whole measure of x, which extends from here to here. In order to do so, we must find the side length, the missing side length of the right triangle. We can start by labeling sides A, B, and C. Our Pythagorean theorem is a squared plus b squared equals c squared. We don't know what b is, but we do know what a is. A is 8 squared plus b squared equals 10 squared. Eight squared is 64 plus b squared equals 100, which is 10 squared. We can subtract 64 from each side. So that would leave us with b squared is equal to 36. Remember, to get rid of the square, we take the square root. So b is equal to 6, which is the square root of 36. So this measure right here is 6. What you probably notice is that you have a square or a rectangle right here. So if this side is 10, this side must be 10 as well. And then you have 2 triangles that are congruent. This one as well as this one. So if this is 6, this one must be 6 as well. So to find the whole measure of x, which goes from here to here, we can add these three together. 6 plus 6 plus 10. 6 plus 6 is 12, plus 10 is 22. So x is equal to 22. Don't forget that you can always come to tutoring, and if you have any questions, you can always send me an email.